Okay, good evening. Let's start the second day of modulus graphs in our revision class. So last week we have discussed about definition of the definition of modulus, and then how to draw, how to sketch straight lines, and then we discussed about how to sketch a modulus graph based on the definition of a modulus function and the knowledge of sketching a straight line. So I told you in this case, normally in O levels, we used to mark around 5 to 7 points in order to sketch a straight line. And then normally what we learn in coordinate geometry is that we mark 2 points. We mark 2 points and then we can draw a line. Or there's another method I told you by using, like here what we are going to use is we are using 1 point. We just find 1 point, which I later discussed. It should be the turning point, and then we consider the gradient to sketch the straight line. Okay, so here, if I'm not mistaken, in the tude that I uploaded, so use the tude that what we have uploaded finally, like not initially we uploaded a one page of the revision tude. No, not that one. Use the tude that we have uploaded the latest tude. Okay, so here, if I'm not mistaken, someone confirm me, we have done up to question number 11. No? Like I think we have in the process of drawing modulus graphs, we have done up to question number 11, right? We didn't do modulus graphs in this way, no, y equals minus modulus x minus 1. Did we do? I can't remember we did this. If possible, can someone send me a message in the chat mentioning whether we have done this? Oh, yeah, exactly. So I asked you to do up to, no, we didn't do these questions, but I told you to do up to question number 11. Okay, now, like what I want you to do is like take a rough paper, or you can even do this in your same book, that's fine. Or take a rough paper and then think how to do question number 12. So we have done up to question number 11. So here today we will be completing sketching modulus graphs. We will be completing sketching modulus graphs, and then we will be, yes, we will be doing starting modulus inequalities, and we can start past papers even today. So okay, so start this one, do question number 12 in a rough paper, but it's fine if you can do this in the book if you're sure about this. Do this y equals minus modulus x. Y equals minus modulus x. Okay, do this. Oh, this. Y equals minus modulus x. Okay, now in this case, now look at this. When you first consider the definition of this, so what is the definition? You get, so minus is something that is outside the modulus. I told you when you have a minus outside the modulus, it is not impacted, like it won't change by the definition of a modulus. So minus will be as minus. So you get minus x, and here it is minus x, which gives you x. So this is when x is greater than 0, and this is when x is less than 0. So basically you have to draw y equals minus x, this one, and y equals x. So this is when x is greater than 0, and this is when x is less than 0. So here now look at this, what happens if you have done this lesson modulus graph, then you know what happens here. But let's say there's someone who is learning this lesson for the first time. There is someone that who is learning this lesson for the first time, and here you draw y equals minus x. Okay, so y equals minus x. So what is the turning point? And we know these type of graphs without the intercept, where the intercept is 0, is going through the origin here. So here if you draw y equals minus x, so what is minus x? Is having a minus gradient, and it goes in this way. Minus x, and it goes in this way. And it goes in this way. And then, so this is y equals minus x. And what is the other one? Y equals minus x. Y equals x. So it is even going through the origin. So you draw this in this way. This is y equals x. Now the thing here, because we have been drawing modulus graphs last week, and normally what we do, if someone is learning this for the first time, what is the first thing that comes to your mind? Okay, we know this is only valid. And then suddenly you erases this part. But always you have to go with the definition. You have to go with the definition, and not that every time the modulus graph is a V-shaped graph. No, it's wrong. So here, look at this. We have y equals minus x. We have y equals minus x, which is valid only when x is greater than 0. We have y equals minus x. So y equals minus x is valid only when x is greater than 0, which means this line is only valid when x is greater than 0. So only this part is valid. Only this part is valid, and this part is not valid. So here you have to take out this part, not this one, because this is equal, this is valid only when x is greater than 0. And in the meantime, this one y equals x is only valid when x is less than 0. When x is less than 0, which means this part is not valid. This straight line is only valid when x is less than 0. So this graph, the inverted V-shaped graph, is y equals minus modulus x. Okay, so then what you need to understand here, okay, here what you need to understand, when you have a minus in front of the modulus, okay, when you have a minus in front of the modulus, most of the time, because I have to use the term most of the time, because not always you get, like in our syllabus, I admit every time you get it, when you have a minus when you have a minus in front of the modulus, you get an inverted V-shaped graph. Okay, but that doesn't mean that every time you are getting this, there might be different graphs, but we can say in our syllabus, in most of the times, if you have a minus in front of this modulus, you are not getting a V-shaped graph, you are getting an inverted V-shaped graph. Okay, so this is what you get. Okay, throw this and then do question number, so this is 12, then do question number 13. Y equals 2 minus modulus x. So even here, now you know by experience at the beginning of this problem, you know, when you have a minus, you're supposed to get an inverted V. You're supposed to get an inverted V. Okay, do this. Do question number 13, and when you do it, so it's better if you can send me a message mentioning you have done it. Okay, good. So here, like if you consider the definition, it's 2 minus x and 2 minus x, which gives you 2 plus x. So this is when x is greater than 0. So this is when x is less than 0. Okay, this is when x is less than 0. That means you're supposed to draw these two graphs, y equals. So here this is minus x plus 2. And this one, it's y equals x plus 2. So it's better to write this x as the first one, because then you have this exact format, y equals mx plus c. And then you know that the gradient here is m. You know that the gradient here is m. Okay. Okay, so then like find one point. Here you can use the intercept. So I told you to find the turning point. So what is the turning point? That is when x equals 0. So when x equals 0, y is equal to 2, which means it is going through the point 0, 2. And even here, when x equals 0, y is equal to 2, which means it is going through the point 0, 2. It is going through the point 0, 2. Okay, so here draw the two straight lines which is going through this point 0, 2. Okay, so here it is going through this point 2. So y equals minus x plus 2. When it is minus, we know it's a minus gradient, minus x. So here it's in this way. But when you draw this, now you have the experience. Now you have the experience that this straight line y equals minus x plus 2, y equals minus x plus 2 is only valid when x is greater than 0. So that we know this is only valid. So you can just draw this part. No need of drawing this one. Even here, y equals x plus 2, the straight line that is going through this point with a gradient plus 1. So it is in this way. But I know this is only valid. This is only valid when x is less than 0. When x is less than 0. So this is y equals minus x. Sorry, this is y equals x plus 2. Y equals x plus 2. So this is the graph y equals 2 minus modulus x. So first thing, before solving modulus inequalities using the graphical method, you need to have a clear idea, or you need to have a clear understanding about how to sketch any type of modulus graph, because we don't know in the exam what type of a graph you might get. Okay, so like there have been changes in the 2023-22 paper. There was a small change, like the type of modulus graph that you have to sketch. So we need to have a clear idea about which type of graphs, like we need to have a clear idea about whatever the modulus function you have been given, how to sketch the graph. How to sketch the graph. These are not exact 100% perfect diagrams which has been drawn to a scale. No, these are just sketches. Clear? Good. Okay, so then let's do one more question from this one. Do question number 12, 13, do 16. Yeah, do question number 16. So after these, do question number 16. 12, 13, and do question number 16. Okay, so do it, then I'll even start this. Y equals 2 minus 2 times x plus 1. Okay, okay, so here, then we can do it this way, write the definition based on this is being positive or negative. We have 2 minus 2 times x plus 1. 2 minus 2 times x plus 1. Okay, so here then we have 2 minus 2x minus 2. And then you can see these two cancel off, which gives me minus 2x. So I'm getting this y equals minus 2x when x is greater or equal to 0. And from this end, here it's clear, it becomes minus minus is plus. So here it's basically, what do we get? Here is minus in this one. So this becomes the minus when x is less than 0. When x, sorry, not less than 0, sorry. It's x plus 1 is greater than 0. So x should be greater than minus 1 and less than minus 1. So when the term inside the modulus is negative, you get the negative of it. So here these two becomes plus. So giving you 2 plus 2x plus 2, which means here I have y equals 2x plus 4. So we need to understand what are the two graphs that we need to draw here. Okay, what are the two graphs that we are supposed to draw here? It's y equals minus 2x in this case, and here it's y equals 2x plus 4. And then find the turning point. What is the turning point? Turning point is when x equals minus 1. So substitute x equals, what is this? Oh, it's a complement. No, I was wondering whether it is a question. So I'm fully capable of understanding these materials, even though I'm a Sinhala medium student. Thank you, thank you, thank you for the compliment. So here when x equals minus 1, and then we have y equals minus 2, minus 1, where y is equal to 2. So then here the turning point is minus 1 and 2. And this one, when you substitute x equals minus 1, y equals, this becomes minus 2 plus 4, giving you y equals 2. So then it is minus 1, 2. Okay, so now let's sketch the graph. Okay. Then, so here the turning point is minus 1, 2. The turning point is minus 1, 2. Here we have minus 1, 2. Going through this point, what is the first one? When x is greater than minus 1, we have minus 2x. So when it is minus 2x means the intercept is 0. So it's going through this. It is, so let's draw. It is going through this point. And we know it is only valid after x. When x is greater than minus 1, only it is valid. So this is y equals minus 2x. So this is the origin, and this end y equals 2x plus 4. So here it's having a gradient of 2, but only valid when x is less than minus 1. Only valid when x is less than minus 1. So here it is y equals 2x plus 4. So this V-shaped graph is the graph of y equals 2 minus 2 times x plus 1. 2 minus 2 times x plus 1. Clear? Got it. Okay. Tell me who got this one. Send me a message in the chat mentioning you got it or correct or something like that, which gives the idea. So can you tell about how to manage sports with studies? So we can have this chat in a theory class, because here it's the revision class and we are just focusing. We are doing this class in 2-hour time slots, so maximum 2.5 hours. So it's not, I don't think it's ethical to take like, because it's a big topic to talk about. In a theory class, we can have that topic, we can have that chat, because we need like a good, I can't just say, okay, this is what you're supposed to do. So then at least like 15 to 20 minutes will be needed. So here I think it's not ethical to just talk about it, because here the students have joined somehow to revise them, and the ones who don't know these stuff to learn it. No. Okay. But if you attended our theory classes, or if you attended my physical classes, you can just directly approach me and we can have this conversation. Or if you attend in the physical classes, still you have that, you can just, I'm sorry, approach in the theory classes. If you are an online student, you can send me a message. So when the suitable times come, I can, when the suitable time comes, I can just have a small discussion about it, how to balance the work. Okay, good that you got this answer. Okay, and the other thing that we will be continuing this revision. So I told you, but last week I clearly mentioned it. I will be revising the main lessons only up to differentiation. Okay, so I told you, because this is a thing that we are doing mainly, focusing the students who have joined to our theory class as new students. And let's say from next month onwards, there might be students who is planning to do their second shy for them. So I told you, like, you have to attend the theory classes properly from this month onwards, from differentiation onwards, through the revision. Like this revision, I'm not going to continue till next year. I told it clearly. We will be doing all the main lessons, including, but when I do it, like I do it in a complete way, not in a partial way that only theories have been done in this one. You have to watch a separate recording to see how to solve the questions. No, all the lessons, all the theories, and all the problems, including past paper questions, will be discussed during the class hours. So here, all the main lessons till differentiation will be covered through this as a help for the students who have joined later to our class. And the students, there might be students who are not attending our classes, that is fine, but they want to cover up the initial lessons. And for any type of those students, you can do this. Okay, then, okay, write this, write a note using a black pen, and in front of that using a red pen, write using a black red pen. Write in the normal way we write notes using a black pen, write note, and in front of that using a red pen, write this: horizontal straight lines parallel to the x-axis. Horizontal straight lines parallel to the x-axis. Horizontal straight lines parallel to the x-axis. Okay, horizontal straight lines. Okay, now look at this. If I consider the straight line y equals 1, so y equals 1 means, like, despite of the x value, the y value is every time the y value remains 1. So whatever the x value is, or regardless the x value is, y value will every time be 1. So let's say if you just substitute x equals 0, you still get y equals 1, which means it is going through the point 0, 1. If you consider x equals 2, still y will be 1, because there is no any x here to substitute that x value. There is no any x value to substitute here to the change in x value. So here, whatever the x value we are substituting, regardless the x value, the y value remains 1. So we say these graphs, the y equals 1, are horizontal straight lines parallel to the x-axis. Parallel to the x-axis. So here, this is y equals 1. Horizontal straight lines parallel to the x-axis. And here if I take another one, let's say we have this, which is going through the point 2. This is y equals 2. And let's say going from here, this is y equals minus 1. Okay, so straight lines in the format of y equals k, straight lines in the format of y equals k are horizontal straight lines parallel to the x-axis. Horizontal straight lines parallel to the x-axis. Okay. Okay. Write it this way. A small thing. Write it this way. Write it this way. Straight lines in the format of straight lines in the format of straight lines in the format of y equals k, y equals k, y equals k are horizontal straight lines are horizontal straight lines parallel to the x-axis, are horizontal straight lines parallel to the x-axis. Are horizontal straight lines parallel to the x-axis. Okay, and then just draw this. You don't have to draw this one. Just draw this Cartesian plane and get these answers. Okay. Okay, now do question number 17. Now do question number 17. Do question number 17. Okay. Okay, so here, question number 17. Now look at this. If you, when I ask you to do something, better if you can send me a message, especially because this is a 100% online class. So then I can't see whether students have done this, and we don't have the Zoom chat to check whether any of the students have sent us messages. So better to the students who are following the exact live, better to send me a message soon after you complete this. Okay, so question number 17 is y equals modulus x plus 1 minus x. So here, if this directly comes out, it's x plus 1 minus x, giving you 1. Basically, you have y equals 1 here. And here, when it becomes minus x plus 1 minus x, so minus x gives you minus 2x plus 1. Sorry, minus 1. So this is when x is greater than or equal to minus 1, and this is when x is less than minus 1. Less than minus 1. So here, now look at this. If you draw this, the turning point is x equals minus 1. And if you draw this straight line, so what are the two straight lines that you're supposed to draw? Y equals x and y equals minus 2x minus 1. So here you don't have to worry about the coordinate, because whatever the x value you substitute, I told you y will remain as 1. That means it is going through the point minus 1, 1. And even here, when you substitute x equals minus 1, you get y equals minus 2 minus 1, 2 minus 1. So y is equal to 1, which means this is even going through the point minus 1, 1. Okay, so mark that point, y equals minus 1 plus 1, and here it is clear. The intercept is minus 2, so you have to draw a straight line which is going through this point and having an intercept of minus 1. So then minus 1 means the intercept of minus 1 means it is going in this way. A gradient is minus 2, so it goes in this way and it is having an intercept of minus 1, but we don't have to mark the intercept because we know this is only valid when x is less than minus 1. And then the next straight line that you have to sketch is basically y equals 1. Is y equals 1. So what is y equals 1? The straight line, that is the horizontal line that is going through 1, but it is only valid when x is greater than minus 1. This is only valid when x is greater than minus 1. Okay, so this is the straight line y equals 1. So this is the shape of y equals modulus x plus 1 minus x. Clear? Okay, so that is the thing that I want you to say, that there is nothing that every time the modulus graph should be a V-shaped graph or an inverted V shape. No, there are different shapes. It can be an inverted V shape and it can be graph in this way. So we can't be limit to any, okay? We can't be limit to any of these. Mentioning, okay, this is the graph that I'm supposed to get. No, it can be different shapes, different shapes. But the thing that if you have a normal idea, let's say if it is y equals modulus, you know it is a V-shaped graph line on the x-axis. If it is modulus minus someone, it goes down. When it is modulus plus someone, it comes up. And then when we have a minus in front of the modulus, you are getting inverted. So those are the things that the special points you need to know. So then when you are drawing the graph, you know that the graph that you have got is correct. So those are the points that you will be using to read, like to make sure about the graph that you have sketched, whether it is correct or not. Okay. Okay, so let's do one more question and move on to modulus inequalities. Do question number 18. Do question number 18. Okay. Okay. So let's say question number 18 is the question that I asked you to do. So if we consider the recent years, we haven't got this type of graph, but I think we had a similar one in yeah, in 2001 was the last year that they have asked you to draw a graph like this, consist in a modulus, and even outside the modulus, we are having a variable. So 2001, which means 25 years back, was the last year that they have asked to sketch a graph in this way. But what I say, when we learn a lesson, we should be completely learning the lesson, not only considering the facts or the points, which has been tested in the recent years. So that is what we call as learning. Even if it is a theory class or even if it is a revision class, when we learn, we have to learn completely 100%. Later, when A levels is coming nearby, then you can just focus on the type of questions, the type of structure of questions which has been tested in the recent, let's say, for the last 10 years. So that is focusing on those questions are fine. But when you learn, you have to learn the every theory and the concept in this lesson. Okay, so I told you this one has the last year that we have been given to draw a graph like this was in 2001, 25 years back. Because there are some instances such questions have been repeated after a huge interval. For example, there's a lesson called mathematical induction. So that is the first question in the PO Maths paper. That is the first question in the PO Maths paper. And in this mathematical induction, there was an inequality. So that inequality type question, the last it was tested was in 2003. Okay, the last year we had inequality for this mathematical induction was back in 2003. And then in 2025, now this year, last year, again they gave this mathematical induction based on an inequality. So after 22 years, so there are some instances after a huge silence, those questions have been repeated and tested. Okay. Okay, so then question number 18 is y equals modulus 2x plus 1 plus modulus x. So here when you consider this, it directly comes out giving you 3x plus 1 when x is greater or equal to minus half. No? So this becomes 0. The turning point here is x equals minus half. 2x plus 1 equals 0. So x equals minus half. And from this end, 2x plus 1 plus x giving me minus 2x plus x is minus x minus 1. So I have done the simplification directly. X is less than minus half. Okay. Okay, so what are the two straight lines that we have to draw here? Y equals 3x plus 1 and y equals minus x minus 1. So in this end, if you substitute the turning point x equals minus half, this you get y equals minus 3 over 2 plus 1, which is y equals minus half. No? So it is clear it is going through the point minus half, minus half, minus half, minus half. Here if you substitute x equals minus half, y equals minus minus is plus half minus 1, which is y equals minus half. So then you have minus half, minus half. Okay. Now there's an interesting, not interesting thing, the gradients are different, not that interesting. The gradients are different. Now look at this. So draw the two straight lines separately and then you can figure out what are the paths that you need to consider. So it is going through minus half, minus half. It is going through minus half, minus half. So minus half, minus half. No? Yeah. It is going through minus half, which means going through this point. Okay, now look at this. What is the straight line we have to consider when it is greater than minus half? It's y equals 3x plus 1. So 3x plus 1 means it's going through this point having a gradient of 3. So having a gradient of 3 means it's having a greater gradient, higher gradient, and having intercept of 1. So here it goes in this way. Here we have y equals 3x plus 1, which is having intercept of 1 and gradient of 3. Clear? Gradient of 3. And then And then look at this. The next one is that you're supposed to draw. It's the 18th one. Right. Okay, never mind. It's the 18th one. Do the 19th one too then. So good that you got the 18th one. So as an additional one, do the 19th one too. I just saw that you were asking to do question number 19 a bit late. I asked you to do question number 18. But never mind, then now do both now. After doing question number 18, do question number 19 too. Okay, I'll give you time to draw the last part. Do question number 19. Because like it's fine that you can do like it from your end, it's fine. You have to do additional questions. So doing an additional question is fine. But from my end, I have to erase this entire one, and again I have to do question number 18 from the beginning. So as a tutor, that is not ethical. But from your end, no worries. You are doing an additional question, which is always a bonus. Okay, do question number 19. So we finished question number 19. Send me a message. Only one is missing, only one part is missing in here. So you have to draw y equals minus x minus 1. Minus x minus 1. Okay, so when you draw y equals minus x minus 1, I was just reading the messages now. You from the beginning you have mentioned, and look at this. It sounds like a complaint, sir. Sir, you told us to do the 18 question. We did the 18 question, and now we are doing the 19th. Okay, so those are small things. I just look at the question 19th question, and I ask you to do question number 18. But now it's better that you have drawn to both the graph question number 18 and 19. Okay, so what is the missing part here is minus x minus 1. So minus x minus 1 means it is having a gradient, minus gradient. But now look at this. Here we are having a, now look at this, here we are having a plus 3 gradient. No. And here if this is the plus 3 gradient, plus 3 minus 3 is in this way. Plus 3 minus 3 is in this way. But here we have minus plus 3, and it is not minus 3, it is minus 1, which means the inclination is a bit low. Like if I say in this way, if you consider this is plus 3 and minus 3, the gradients, the inclinations from both sides are symmetrical. The inclination from both sides are symmetrical. Okay, if you have plus 3 minus 3, from this side this is this incline, from this side this is this much incline. But in the case of 3 like 3x minus 1, so here the gradient is 3 and here it's not minus 3, it's minus 1, which means the inclination is a bit less in this way. It's not a V-shaped one. It's not a symmetrical perfect V. So one arm goes in this way. One arm goes in this way. So here you can draw this in this. This is y equals minus x minus 1, which means this is the graph of y equals modulus 2x plus 1 plus x. Clear? Okay, now, so we have done all these types of modulus graphs. Send me a message in the chat mentioning whether you understood this clearly. So now sketching modulus graph should be perfectly fine to all of you. I need everyone to respond so then I have a clear idea. Good. In a rate of 1 to 10, how tired? No, I'm not tired because even last week I told you we are having a court vacation, but from next week onwards I'll be tired because last week and this week we are having the court vacation, means the courts are like not processing the Supreme Court and the Court of Appeal. So I didn't have courts in the morning. So I just went to the 2028 class around 2 o'clock. And then today, now I have this class. Even last week was the same, but from next week onwards, when we have this court where I go in the morning to the court and then come to the 28 class and then do this one, then I'll be tired. But I'm just used to it since he has not, since after I started classes or anything, I've been used to this since my school days with all these extracurricular activities and academics and all. The thing is, like these days, I'm having a back pain. I'm not sure whether it is a slip disc or I have to check it. And I just went to a physio today in the morning. I don't know how did it even come, because like normally I played a football match last Wednesday and nothing happened and it was perfectly fine. But there was a small back pain towards the lower part of the vertebral column, which was like gradually developing. I didn't care about it, but now it's a bit it's a bit worsen, a bit worse now. So I have to check that. So that is the problem I'm having. Like I don't know whether you have realized when I just bend in this way, like I just do it in a normal way because I'm not sure whether that happens. I feel like a current is passing. So I have to take proper treatment. But anyways, thank you for answering. Like thank you for asking that. Like asking, so how tired are you in that case? That means it's something carried, but good. Okay, so then let's move on to solving modulus inequalities then. Okay, okay. Then write in this way, write the main topic, solving modulus inequalities. Solving modulus inequalities. So was there any A-level question that was given to modulus inequality and to draw the positive portion of one graph? Wait, what is this? Draw the positive portion on one graph and the negative portion. I can't clearly understand about the question that you're asking, but based on this last part where you have to draw one portion of one graph and the negative of the other one in no, but we haven't got those type of graphs. If you refer to this all these past paper questions, we don't have this, the graph type that you are mentioning. Okay. Okay, so then there are two ways to solve modulus inequalities, two methods to solve modulus inequalities. One is called as the graphical method. One is called as the graphical method and the other one is known as the algebraic method. But mainly we are focusing towards the graphical method. The reason why we focus in the graphical methods, if you look at these past paper questions, including the 2026, which is not here because the paper was held last Monday. So including the 2026, every year in this modulus graph question, they have been first asked us to sketch a modulus graph and then we have to solve a particular inequality. Okay, first we have to sketch a modulus graph. Okay, first we have to sketch a modulus graph. First we have to sketch a modulus graph and then we have to solve a modulus inequality. So that means after sketching the modulus graph, like they are expecting us to solve the modulus inequality using the graph, using the graphs, which means the graphical method. Okay, so that is what we are supposed to do. Okay. Okay, so there are two ways, two methods to solve a modulus inequality. One method is that you need to one method is using the graphical method, where we use modulus graphs to solve the inequality, and the other one is the other method is the algebraic method. But here we will be mainly focusing towards the graphical method because that is what is expected in our A-level syllabus. Clear? Okay, not that you can't do the problem in the other way, but we know like after sketching the modulus graphs, you have come halfway through the question and then reverse taking a change and then doing it in another method is a waste of a time because we always know that this hence method or the deducing part means you have done the question partly or partially and then you have to go through the remaining part. Okay, so that is why always when they have given an initial part and then if they have mentioned hence or other ways, the hence method is always easy because you have come halfway through the problem, halfway in the problem through that particular method. Okay. Okay, then write in this way, there are two main methods. There are two main methods, to solve the modulus inequality. Two methods to solve a modulus inequality. The first one the first one graphical method. First one is graphical method. The second one algebraic method. Second one Second one is the algebraic method. Second one is the algebraic method. And then write in this way, but in A levels, but in A levels, but in A levels, we will be mainly focusing on the, we will be mainly focusing on the graphical method. Okay, graphical method. Okay, then write the subtopic, write the subtopic, write the subtopic. Solving modulus inequalities, solving modulus inequalities using the graphical method. Using the graphical method. Using the graphical method. Solving modulus inequalities using the graphical method. Okay, so I could mention this, but that is the thing that you know that we don't have to mention. A modulus inequality is an inequality that is consist in these modulus functions. Okay, so when you have this modulus symbols or the modulus functions on either sides on either sides of an inequality, not both sides, like on either side. It can be in both sides too. So on either sides of an inequality, we specifically name it as a modulus inequality. So you know that idea, so I don't have to write it down. Okay, so here, like, this is what we do. Now let's say you are supposed to solve the inequality such that fx is greater than gx, and let's say these are modulus functions. So these can be modulus functions, this can be a modulus one, this can be a modulus function, both can be modulus, that is fine. So both can be modulus, so you can do it in that way. Okay, and now look at this. So this is what we do. So when you have to solve this modulus inequality, first we sketch the graphs of the two functions which can be found on this both sides of the inequality. So in this case, you draw y equals gx, and then you draw y equals fx. Then you draw y equals fx. You draw y equals gx over here, and you draw y equals fx. So on the same Cartesian plane, you're supposed to draw the function. You're supposed to draw the function which can be found in both sides of the inequality, which can be seen in both sides of the inequality. Now let's just assume that here we have fx. So this is y equals fx, and here we have y equals gx. So gx goes in this way. Now let's say gx is a function in this way, so it goes in this way. So this is y equals gx. So first step is we are supposed to draw the functions of the, draw the, or sketch the graphs of the functions which can be seen in both sides of the inequality. Clear? For example, let's say we have modulus x plus 1. You're supposed to solve this one is greater than x plus 2. So from this end row y equals modulus x plus 1, and from this end row y equals x plus 2. Row y equals x plus 2. Okay? And now the next step is you need to find the x coordinates of this point of intersections, the points of intersection. Find these x coordinates, I'll take it as a and b. Find the x coordinates that you can find. I'll just explain. If you don't know how to find these intersection points, I'll even explain that. Okay, I'll even explain that. So what you have to do is you have to draw this point of intersection, points of intersection, draw the points of intersection, points of intersection, find the x coordinates of the point of intersection. So that is the step number 2. Okay. And then now look at this. This is how you build the logic here. You are supposed to find the range such that fx is greater than gx. So this is the most important part. If you understood this one, you will be able to solve any inequality if you know to sketch the graph. Okay. So now look at this. You are supposed to build the logic that fx is greater than gx. Fx is greater than gx. So in that case, fx is greater than gx. Now look at this. If you look at this area, here we have gx and you can see fx is above that. So here this is fx. So here in this area fx is always above gx. Fx is always above gx. So here we need to find the region where fx is greater than gx. So according to the graph, you need to find the region where fx is above gx, because greater than gx means it should be above gx. So here we have gx and fx is greater than this. Fx is greater than this. So which means in this region, okay, it's clear, fx is greater than gx. So what do we mean by greater? If the graph is located above this one, so that is the greater one. So this is greater. So here we have gfx, it's greater. The black colored one is greater. And then soon after you start, like that's why I told you to find the point of intersection, points of intersection. When you pass this point, now it's clear the black colored one is less than, it's below the blue colored one. The blue colored one is y equals gx, the black colored one is y equals fx. So after A, it's clear the black colored one is below blue, which means it's lesser than blue. It's less than the blue colored one. So in this region, it's clear fx is less than gx. Fx is less than gx. Fx is less than gx. Okay, fx is less than gx. Clear? And then when you move on in this way, after this point of intersection, again it's clear that fx is above the blue colored one. The black colored one is above the blue colored one, means fx is greater than gx. So then we can consider this region fx is greater than gx. So here, according to the graphs, what do we consider? The graph or the function which is greater is the graph which is located above. So here in this region, the black colored one, fx is above the blue colored one, which means fx is greater. We are supposed to find the range such that fx is greater than gx. Okay, so this is okay. And then after this point of intersection, it's clear. Now the black colored one is going below the blue colored one, which means this region you can't consider, because we need to find the region such that fx is above gx. Means fx should be above this one, greater than this. So this region, no, it's less than that because it is below this one. And again after this b, it's clear fx is greater than this. So then you have these two regions. So you can write this fx is greater than fx is greater than gx when, write this answer. So what is the answer? Write the region. So what is this region? X is less than a, o, x is greater than b. X is less than a, o, x is greater than b. So that is how you write the region. So now let's say they're asking this question in the opposite way. Fx is less than gx when? Are they asking the region where fx is less than gx? So that means gx is greater. So here it's clear in this region fx is greater. No, you can't accept this one because fx is greater. Here gx becomes greater. Now look at this, gx becomes greater. Gx becomes greater in this region. I'll just color this in the opposite way. In this region, it's clear Gx is greater. Gx is greater. In this region, Gx is greater. So then how to write it? So I'll just erase this, because if not, like, it's unclear. You might be thinking the entire x-axis has been colored. So here, Gx is greater than fx in between a and b. When x is greater than a, less than b. When x is greater than, so this happens when x is greater than a, but when it is less than b. When it is less than b. Okay, x is greater than a, I mean it is less than b. Okay, so this is how we solve this. Let's say you have to solve this inequality. Draw the functions which you can see in both sides of the inequality on the same Cartesian plane, and then find the x coordinates of the points of intersection, and then write down the suitable range. Write down the suitable range such that which satisfies the inequality. So here I told you greater than means the function which is located above. So in this region, fx is above means fx is greater. In this region, gx is above. Here gx is above means gx is greater. Again, after this one, after this point of intersection, fx is above means fx is greater. In this region, fx is greater. Here gx is greater. Here fx is greater. Okay. Okay. Can everyone send me a message? The one who is following the exact live, send me a message mentioning whether you understood this concept and the logic, especially selecting the region such that fx is greater than gx part. I need everyone to send me an answer. Everyone who is following the exact live. Okay, got it. No, everyone, clear, 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 clear. I got, sorry, I got a call here. It's hmm. No, the trigonometry part, the basic, I think I didn't deleted it. I have just put it as private because the thing we are doing trigonometry for the 2028 batch these days. So when we are doing it to the 2028 batch in a theory class, where even these online students, where even these online students have to like pay and attend classes, so then it is not good to keep the recordings in YouTube. So that's why I have just like not permanently, temporarily put it in private. But later, after completing the 2028 trigonometry part, I'll be asking them to not re-upload, then again put it as these public videos. Okay, 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 clear. Okay, then let's write in this way. Write in this way. Single okay, write in this way. When solving a modulus inequality, when solving a modulus inequality, give me 1 second, not 1 second, 1 minute, sorry. Okay. Okay. Uh, so then, okay. So when solving modulus inequalities using the graphical method, the following steps should be followed. Uh, so we have to repeat following. No, never mind. The following steps should be followed. The following steps should be followed. So let's finish the class somewhere around like 11:45, maximum 12. Okay. We have to follow the following steps. Okay. The first step, draw the graphs of the modulus functions. Draw the graphs of, or sketch the graphs of, both are fine. Ideal word is sketch, but since we have written draw is fine. Draw the graphs of the functions which can be seen which can be seen which can be seen in both sides of the inequality, which can be seen of both sides of the inequality on the same Cartesian plane. On the same Cartesian plane. Okay. Okay. Sorry, I got like back-to-back calls regarding a case that we are handling. Okay, so here then I told you the first time that we have to sketch the graphs of the function which can be seen in both sides of the inequality on the same Cartesian plane. Next one, step number 2, find the x coordinates of find the x coordinates of x coordinates of the points of intersections x coordinates of the points of intersections of the two graphs of the two graphs of the two graphs. Okay, of the two graphs. Clear, of the two graphs. Okay. Then the next point, point number 3. Point number 3. Write the range of x. Write the range of x. Write the range of x. Satisfying the given inequality. Satisfying the given inequality. Satisfying the given inequality. Okay. Okay, then write in this way. Write in this way, look at the board. Consider fx is greater than gx. This one, consider fx is greater than gx. Consider fx is greater than gx. Fx is greater than gx. Okay. Okay, then next line. Next line. Then we have to then we have to then we have to sketch the graphs of sketch the graphs of sketch the graphs of y equals fx and y equals gx. Y equals fx and y equals gx on the same Cartesian plane. On the same Cartesian plane. Same Cartesian plane. Okay. Okay, then draw this and then write down both of these inequalities. So then you have idea. So here the main thing that you need to understand is what do we consider the function which is greater. So the function which is in the range, okay, in the range we are considering, if the graph is above, the graph which is above is considered to be great. The graph which is above is considered to be great. Is considered to be greater. So draw this same one, so it's clear. So all the time keep in mind the fact that what we consider to be the greater one is the function or the graph which is, so it's actually the graph, not the function, which is located above. The graph located above at a given region is considered to be greater in that region. Okay, I'll give it as a point. Can you send me a message in the chat after you complete this? After completing this, send a message in the chat. Okay. Okay, so I told you that I got some back-to-back calls regarding a case that we did, but we lost the case. It was a bribery case. Okay, it was a bribery case, so that's why I'm telling you, like whatever the amount of the bribe that he or she has taken, like look at the punishment. So the thing, he was a Grama Sevaka. Okay, he was a Grama Sevaka, and he has taken a bribe of 500 rupees. He has taken a bribe of 500 rupees to for the purpose of passing the Samurdhi loan. 500 rupees, huh? Not dollars or anything. 500, not 500,000. 500 rupees. 500. Just tell me, what do you think the uh, the sentence he got? The sentence means the punishment he got. Just tell me, like probably it's not a you don't get the death penalty for taking bribe. No, okay. So it's a imprisonment. No? Okay, you have to stay in the prison. So just tell me, what do you guess the time period for this 500 rupee bribe? So 500 rupees may be one of your daily expenses if you're having classes, you're coming from home where the bus fee is around collectively 300 rupees or like 200, you eat something. So it's like your daily expense, even more than 500. So tell me, what do you think? What do you assume should be the judgment given, the sentence given? So I helped you. Don't tell me, okay, don't tell me like he got the death penalty because he was not sentenced to death, because the reason is like those are not offenses where you get the death penalty. No, so it's a imprisonment. You have to stay in the jail. You have to stay in the jail. So my question is, assume how many the time period for this 500 rupees. We have 2 weeks, 1 week, 3 weeks, 1 year. What else? Any other answers? Just give me some guesses. Okay, so he got a sentence of imprisonment of 4 years. 4 years. Okay, because the thing is, when you commit an offense like that, it's not one offense. There are few offenses. Like asking for the bribe is one offense. Receiving the bribe is another offense. So when you take bribe, like clearly there are two offenses. One is asking for the bribe, and that is one offense. The other one is receiving the offense, receiving the bribe. So normally, the judgment was given 4 years for each offense, but the 4 years, not 4 into 4 is not 8. 4 plus 4 is not 8. The two punishments should be considered like parallelly, which means we have to consider this 4 years. So he got a 4 year imprisonment, and now like the process is that we are trying to get. We are just putting appeal to the higher court, the appeal court of appeal, and see whether any relief can be taken. But that is the offense. Sorry, that is the sentence that you get 500 rupees for 4 years of imprisonment. And even a similar case happened that was 1,000, no, that was 5,000. 5,000, an archaeological officer. Same thing, he got imprisonment even in 4 years. Okay. Okay, so that's how the rule is strict. If we can properly do the investigations and get all these people, the persons, officers who have taken bribe. So the rules are there in the country. Not that the rules are not there. Clear. Okay, you got this one. Okay, then let's move on to the first example. So question number one. Okay, so question number one. So now I'm not going to explain how to draw the graph. Huh? I'm not going to explain how to draw the graph that we have discussed. So I'll be just telling you, okay, draw this and this. Okay. The first one is modulus x minus 1 is less than 2. So what are the two graphs that you have to draw? Here y equals 2, which is a horizontal straight line. And this is y equals modulus x minus 1. Y equals modulus x minus 1. So on the same Cartesian plane, draw the two graphs that I'll be drawing directly because we know it. Y equals modulus x minus 1 is the straight line going through this. This is y equals x minus 1. And here we have minus x plus 1. Y equals minus x plus 1. So mark these points, the intercept. Clear? So this is the graph of y equals modulus x minus 1. Clear? So was that the primary person you were client? Yeah, Thin is the one who has taken the like, but from his end, he's telling that the story that he's telling us that he didn't take the bribe. So, but we were trying to emphasize some of the weaknesses of the case brought by the investigating party, because the other one are the state lawyers. Because in a criminal case, normally the private bar or the lawyers who are in this private bar are talking in behalf of the ones who have committed the crime, the offense. Okay, there might be innocent people, there might be people like who are really guilty, but we are just talking on behalf of them. And the opposite party will be the state lawyer. So in this case, the bribery commission. Okay, so they are state lawyers. So if it is a normal one, who the lawyers who are talking for the police, the investigation officers, the from the Attorney General's department. So the private bar is always in the side of the ones who have committed the crime, but we can't say that they have whether they have committed. There are so many instances even without committing an offense, the police has put a case, and there are so many those cases. Okay, the ones who might be innocent, who might be guilty. Okay. So here, then what is the next one? Y equals 2. Y equals 2. So this is the straight line, y equals 2. And then I told you to find these points of intersection. X coordinates of the point of intersection. You know how to find the coordinates of the points of intersection, no? How to find it? Solve these two equations simultaneously. So here, solve these two equations. Here we have y equals minus x plus 1. And here this is y equals 2. Which means minus x plus 1 is equal to 2. This goes to this side. Minus x equals 2 minus 1. So this is equal to x equals minus 1. Which means this is y equals minus 1. Okay. So sorry, this is x equals minus 1. So what is this? Y equals 2. And here we have y equals x minus 1. So x minus 1 is equal to 2, which means x equals 3. X equals 3. So here this is x equals 3. This is x equals 3. Okay. So up to that part, we have sketched the two graphs, and then we have marked the point of intersection, points of intersection. And now look at the logic. You are supposed to find the range where y equals 2 is greater. So y equals 2 is the blue colored one. So you have to find the range whether it like the range where it is greater, which is where it is above. So here in this region, the black one is above. After this passes, it's clear that the blue colored is above, which means it's greater. The blue colored one is greater. So again, after this point of intersection, it's clear the blue colored one is less, the black colored one is greater, or the black colored one is located above this. So then you can write the final answer. A modulus x minus 1 is less than 2 when, what is the answer? X is in between minus 1 and 3. X is in between minus 1 and 3. Okay, X is in between minus 1 and 3. Is it clear? So again, can you send me a message mentioning say that is clear? Because previously I asked the question based on example, a general example, fx and gx, but here I have asked this example based on a exact question. Can you send me a message, everyone, whether this is clear? Everyone, can you send me a message mentioning whether this is clear? Okay, clear. Clear. Okay, good. Okay, then do this one and then do the second question. Do this one and then do the second question in the institute, and we will be doing modulus class for 4 days. Now don't compare. So in the theory class, even we did this for 4 days, but in the revision class, we are even doing this for 4 days. No, but look at the time period in the theory class. It's we have done this for 4 days, but 4 hours. One day is 4 hours. So 4 days of 4 hours, but in the online, the revision class, it's just 4 2-hour time slots. Okay. So we are not going to finish this lesson next week, not the 24th. We'll be doing it even week after. We'll be doing it even week after, and then completing modulus functions in 4 2-hour time slots, which means next week and week after. Okay, so then do this one and then do question number two. Do question number two. Okay, then the time would extend, right, sir, to finish this revision. No, but the thing is like, let's see how we can do it. But normally, even initially, I was planning to do this modulus graph in 3 days. But when I do it, like because we need to do more questions, I told you that I will assure that even if this is a revision, still I'll be covering most of the past paper questions and the question types that has been asked in past papers in the recent years. So for that purpose, we need some time. So let's see how we can do it. But I can't say exactly, like let's say for like when you're doing velocity time graph. So we did velocity time graph for 5 days. No? So when you're doing the velocity time graph revision, I won't be talking about these linear motion equations because I told you we just did that part, but I won't be doing this. I'll be entirely focusing on velocity time graphs. So one day we can do the horizontal motion. So we can do that in four days, probably. four 2-hour time slots. So we can do it in that way. So you don't have to worry about the time period that might take to revise all the lessons we have done so far up to limits, no, up to limits and projectiles. Yeah, up to limits and projectiles. But if you just start from differentiation onwards, and let's say that we continue this throughout this year, then the initial lessons you can cover up. You can revise all them. But from the other end, you have to make sure that you are properly focusing on this differentiation and the lessons that we are doing in like relative acceleration, the lessons that we are doing in the normal class. Because those lessons will not be revised or done through the revision. Okay, good. So you have done this one. So the next one is we have, I'll do it here, x plus 2 modulus is greater or equal to 3. X plus 2 modulus is greater or equal to 3. Clear? Okay. So here, what are the two functions that you have to do? Y equals 3 and y equals modulus x plus 2. Y equals modulus x plus 2. And here, in this case, look at this. X, so x plus 2 is going through this. So I'm not explaining how to draw like, because we have comprehensively done the part sketching the graph. Now I'm not going to explain in detail how to do that. It is going through this point, x plus 2. Now y equals x plus 2. And this point minus x. Y equals minus x minus 2. And then draw the graph y equals 3. So these points are like, even though we mentioned them as bonus points, it's better if you can mark them. It's better if you can mark them because that gives you idea the next line that you have to draw is y equals 3. So it goes in this way. It goes in this way. So find these points of intersection. Find these point of intersections. So what is this? How to find this? Solve these two equations simultaneously. This is y equals 3. So we have y equals 3 and y equals minus x minus 2. So minus x minus 2 is equal to 3. Minus x is equal to 5 and x equals minus 5. X equals minus 5. So this is minus 5. And here y equals 3. Solve these two simultaneously. Y equals x plus 2. Giving you x plus 2 is equal to 3 and x equals 1. So then this is equal to 1. So then look at the logic. We are supposed to find the range where x plus 2 is greater, which means the black colored one is greater. So it's clear the black colored one is greater. In this region, it's greater. In this region, it's greater. The black colored one is greater, it's clear. And in this region, the blue colored one is greater. So again, after this point of intersection, the black colored one is greater. But here there's an equal mark. So when there's an equal mark, you have to consider the points of intersection. So when we have an equality, we have to consider the points of intersection. So then you can write the final answer. Modulus x plus 2 is greater or equal to 3 when x is less or equal to minus 5 or x is greater or equal to 1. When x is less or equal to minus 5 or x is greater or equal to 1. Okay, hands up again, not hands up, sorry. Tell me who understood this one and who got this answer. So everyone, understood, got the answer. Send a message, understood, got the answer. Understood, got the answer, everyone. So then let's move on to the next one. I'll just give some 2 points here, 2 important points here. Got it and understood, everyone. If you didn't get it, that's fine, but send me a message mentioning got it. Got it. Good. Okay, then write these 2 points. One point is we need to understand the inequality changes at the points of intersection. So that is one thing we need to understand. Here it's clear. Before this one, before this point of intersection, the black colored one is greater, but after this point of intersection, the black colored one is less than this and the blue colored one is greater, which means at the point of intersection, at the points of intersection, the inequality changes. We have to consider that. So that is the reason I told you to find these points of intersection. So here the inequality changes. Again, there the inequality changes. Clear? That is the first one. And the other one is in this case in the graphical method. I told you the graph which is above on a given region is said to be the greater function. Is said to be the greater function. Good. Okay, then write these 2 points. Write these 2 points. First, put a red star mark and write in a normal pen. Put a red star mark and write in a normal pen. When solving modulus inequalities, when solving modulus inequalities, when solving modulus inequalities, the graph which is located above, the graph which is located above, the graph which is located above in a given region in a given region is said to be the greater function. Is it grammatically correct? The graph which is located above in a given region is said to be the right no is said to be the greater region, is said to be the greater function. Is said to be the greater function. Okay. Okay, the next point, put the next star mark. Put the next star mark. The inequality changes. The inequality changes. The inequality changes at the points of intersection. At the points of intersection. Okay. Okay, then do question number. So that is completed. No, the inequality changes at the points of intersection. Okay, then put this. Sorry, do the question number 3. So question number 3, same thing, same drill. Do question number 3. So question number 3. No, question number 3. So let's finish after this one. Let's finish after this question. And can someone, like when we start next week's class, can you send me a message reminding? So we need to do the special special points regarding modulus functions. Okay. Okay. So make sure like next week when we start the class, someone tell me, so we need to do this. You can even write it using a pencil, special points, like special points or special things, let's say I'll give the exact topic for just remind me that we need to do this special points regarding modulus functions. Okay. In this case, what are the two graphs that you have to draw is y equals x plus 2 is 1 and the other one is y equals modulus x minus 1. Y equals modulus x minus 1. So first row modulus x minus 1, which means it is going through this point. Modulus x minus 1 going through this point. This is y equals x minus 1 and y equals minus x plus 1. Y equals minus x plus 1. And then what is the next one? Y equals x plus 2, which is a straight line that is going through this point, intercept of 2. Okay. Okay, now look at this. When I'm drawing this y equals x plus 2, tell me what can you say about y equals x plus 2 and this straight line? So now I'm supposed to draw y equals x plus 2. So tell me what can you say about y equals x plus 2 and this straight line? Y equals x plus 2 and this straight line. What can you say about these two straight lines? Y equals x plus 2 and this straight line. They are parallel because the two gradients are equal. So when the gradients are equal, I told you The lines are parallel. The lines are parallel. It goes in this way. So then this is y equals x plus 2. Find the point of intersection. This one. Find the point of intersection. So here what has been intersected is y equals x plus 2. And this is y equals minus x plus 1. So then x plus 2 is equal to minus x plus 1. You get 2x equals minus 1, giving you x equals minus half. So x equals minus half. So you have x equals minus half, clear, okay. So then look at the inequality. You're supposed to find the range that the blue colored one is greater. So here the black colored one is greater. So after this point of intersection, so only one point of intersection means the inequality only changes once. So after this point of intersection, it's clear that the blue colored one is greater. It's clear that the blue colored one is greater. Okay, it's clear that the blue colored one is greater. Then there is no any change of the inequality because after this point, there are no any point of intersections. Points of intersection. Okay, then you can write final answer. Modulus x minus 1 is greater than x plus 2 when x is greater than minus half. When x is greater than minus half. Okay. And I'll just show you. Do you know what is the importance of drawing these two as parallel lines? So those facts you have to consider. You have to consider the inclinations here. What is the importance of drawing these two as parallel lines? Like seeing that these are parallel lines and drawing them. I'll show you the importance here. Now look at this. Now let's say you draw y equals modulus x plus 1, x minus 1 in this way. So you draw y equals modulus x minus 1 in this way. And then you're drawing the next line, y equals x plus 2. And you don't realize that the two gradients are equal. You don't realize that the two gradients are equal. So you're just drawing the line because these are rough sketches. So that is the main point here. We have to consider these small details because these are rough sketches. If we are drawing a perfect graph according to a scale, if you're drawing a perfect graph according to a scale, then you don't have to worry about this. You don't have to worry about this because you have drawn them according to a scale perfectly. But these are rough sketches. Now look at this. Without realizing the fact that the two lines are parallel, you draw the second line in this way. And you draw the second line in this way. I know you won't do that, but let's say you do this. So what is wrong here? What is wrong here? Tell me what is not here, but what can you see there? Tell me what is not present here. So what is not supposed to be happen here, but what has happened there? There is an additional intersection point, no? So when there's an additional intersection point, the inequality changes. See, like if you do that, if there is an additional intersection point, the inequality changes. Because intersection points play a vital role in when solving modulus inequalities using the graphical method. Intersection points play a vital role. So that's why we need to make sure that we draw even though these are rough sketches, we have to make sure that we have marked the points of intersection correctly. We have marked the points of intersection correctly based on the inclinations of the straight lines. So here if the two lines are parallel, it's in this way. If this one is having a higher gradient, it's going in this way. If this one is having a less gradient, it's going in this way. So we have to consider these facts. Okay, so then we're done for the day. So next week when we start the class, make sure that you remind me. So we need to do this, to the special points regarding these modulus functions. So we can do that part, and then next week we will be doing past papers, and most of the past paper questions will be discussed next week. And then there are some special functions and using these substitutions, special functions and using these substitutions in modulus inequalities will be discussed in the fourth day. Clear? Okay, so